Hey Eli, how are you?
Good. How are you?
I'm doing great, thank you. I'm working on making sure I have the study guide uploaded. So if you'll bear with me one minute, sorry. I thought it was already uploaded, but it wasn't.
That's okay.
How are you feeling?
All right.
Are you all recovered from the plague?
We we still have the cough.
Oh, I hate that. Yeah, I think my cough lingered a little bit longer when I had it, and it seemed. I'm just thinking about it makes me cough, and it seemed to linger worse like at night. I seemed to be fine, during the day, uh, but then at night I was like, oh, coughing bad.
Yeah, it's pretty well the same with us. You need to keep your throat wet, and that's harder during the night when you're sleeping and all that.
Yeah, I think I had a humidifier going in my room. It's been pretty bad though. A lot of people have been hit with it, that's for sure. Well, of course, everything's running really slow. I've got it. I'm just trying to bring it up now. Did you want me to start any specific place? Like, do you want me to start at the back and work forward, or do you not care?
Things that you think are important that will be on the final sound good.
Okay. Basically, all I did with the final is the review. Um, with it's all I did was regenerate the entire review and take out some questions. So there everything is exactly like the review, like set up and everything. Um I'll just pull it up on my other computer. Um all right, I'm going to do a couple things with you. I'm gonna let me share my screen, and then hey Amanda, hey Mary Faith.
Hey, Miss White. Hi.
Hey Ella, how are you?
Good.
A couple things that I'm going to do with you guys today also is go over like some of the errors that were made even on this latest quiz. There, number 5 on the the thing about the latest quiz. Let me talk about that for a minute. And then number 5 on the review, I can tell you there's one a lot like that on the final. There's one a lot like number 6 on the final. Actually, there's 2 like that on the final. There's one like number 1 on the final. But I also want to, there was one on the last quiz, and it was actually a, trying to open up there we go. All right. Did I just close the fall final exam because I did that? Probably. We'll get there. We'll get there.
Was the last quiz the 5.3 through 5.5 quiz?
Uh-huh.
Okay.
And everybody, I mean, nobody did like horrible on it. I'm just saying I could see that some struggled with this one particular style of problem. So, and there are some of those on the final, and I'm going to explain myself a little bit better in just a minute. If I can get everything pulled up, okay, I'm going to explain myself. Don't panic about what you see on the screen. That's Algebra 2. I sure wish there was a way to clear all, and there just isn't. It's really, I just wish there was a way to pull up a blank piece of paper every time. And I don't want to add any confusion or anything, but I want to make sure that you guys know how to do problems like the one I'm about to show you. Okay, because there's one very similar to this on the exam. Okay, on the quiz, it looked like this. Okay, and when I say there's one similar to this on the exam, I'm going to tell you on the exam, it's going to look more like this. Because I want you guys to understand, without adding a lot of confusion to you, that this symbol right here does not change how the operations in the problem go. You just treat this like an equal sign until the very end. And then the only thing that makes a difference is there's more than one correct answer. So you use a number line graph to show all the possible answers. But as far as the operations are concerned, within the problem itself, everything is done exactly the same. Does that make sense to you guys? Or is that confusing?
It makes sense.
Okay, it makes sense. Okay, I don't want to lose anybody.
At the end, would you put the symbol back?
Yes, because you would have 9 times out of 10, you're going to have to graph it after that. Does that make sense? So that you're actually showing all of the, and a couple people actually do change it to an equal sign so that it's less confusing for them. And then sometimes they'll forget to put it back. But whether you leave it there or you don't leave it there, it doesn't make any difference as long as you remember to put it back at the end. But I'm going to erase this for now, and I'm going to show you this problem because there's 2 problems on the final exam that look like this. Okay? And they're just regular algebra problems, but they basically have something like m plus 3 in the numerator, and then a 6 in the denominator equals some, or not a 6, it'll be a different number. There'll be a number in the denominator, okay? And whether there's a less than, equal than, or whatever sign, what is the first thing I'm going to do on this problem?
Multiply by 6.
Multiply by 6. Good job. That is absolutely correct. I'm going to multiply both sides by 6. And why do I do that, guys?
To get the m and the 3 by itself.
That's right. To get the m and the 3 all by itself, you want to get rid of this denominator. And basically, this it looks like 6 over 1. So you simplify before you multiply. That's what it looks like on this side. So now you have m plus 3. The other way to think about that is this is m plus 3 is being divided by 6. What is the inverse operation of division?
Multiplication.
Multiplication. So now you have this. And there, like I say, there's 2 problems on the final exam that are exactly like this, where you have to do that multiplication first. And it's in the numerator. So it's in the first 8 problems of the final exam tomorrow. You will see 2 problems that are exactly like this. So now what's the next step we're going to do?
Subtract 3.
Subtract 3. Good job. Absolutely, because we're still trying to get that m all by itself. And so we have that as an answer. Now, this wasn't on the exam review packet, but when I looked at the final exam, because Eli said, whatever is going to help me on the final exam, that's what I want to review. Great observation on his part. So I would just add this example to the final review packet that you have, because that was the only one that I could see that looks like it's going to be a little different than what I had. Okay? Everybody good with that?
Yes, ma'am.
All right. Would anybody like me to do one more example that looks like that?
Yes, please.
Okay. Absolutely. Let me make up a problem. And you just add this to your final exam review. X plus 9 all divided by 4 equals 5. What am I going to do first?
Multiply by 4.
Multiply by 4. Good job. That's supposed to be a multiplication. I'm just trying to make sure it looks like that, but I'm not sure it does. Now what do I do?
Subtract 9.
Subtract 9 from both sides. Okay? Like I say, there's 2 problems like that. One more problem that I want to do to make sure that everybody knows what to do. It seems to me, if I have a problem like this, can anybody tell me what I do first?
Divide by 17.
Good job. Divide by 17. I have a lot of people that move a little too quickly, and they will try to subtract 17. And I just want to make sure everybody knows that 17 is being multiplied to x. So you want to make sure you divide both sides. All what you're doing is doing the inverse operation. Okay? Go to here. All right. Number 1 on the final exam review. What do I do?
Multiply by 7.
Multiply by 4.
Oh, wait, by 4. Wait.
No, you multiply by 7 because you're trying to get rid of whatever's going on around the x. So you want to multiply by 7. So that gets rid of this, and it gives you a 28 on that side. Does that make sense?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, what do I do to number 2? What do I do?
You add 11.
Add 11 to both sides. And once I do that, I'm going to get negative 15. Because if I add 11 to negative 26, I get a negative 15. A lot of those we definitely did those in class. Number 4, what do I do first?
Add 7.
Add 7. So if I add 7 to both sides, I'm going to end with this. And now what do I do?
Divide by 5.
Divide by 5. Good job. Okay. What do I do on number 7?
Multiply 8 and 2. And then divide by
job.
9.
Yeah, you can definitely do that. Definitely do that. But what works consistently so that it works for 9 and 10, if you get it set up as cross multiplication like this, then it works every single time.
That makes more sense.
How come the 6k is a negative?
You could set it up, very good question. On that one, you could set up it like this and make the 16 positive, or you could take the, because one of the sides has to be negative since one of the sides is negative. You can pick whichever one you want. You're still going to get the same answer. Does that make sense?
Yes, ma'am.
Okay, great question. You're still, and all you're going to do on that is just reduce it to its smallest terms. So this one, to set it up, you've got 6n equals 32. Now you're going to divide both sides by 6, and you get, and that both of those can be reduced. Oh, that side was negative, and I marked it out with my cross multiplication thing, so got to be careful of that, because we got to make sure that if one of these is negative, then one of these has to be negative. So that's going to give me negative 16 over 3, which is this. Cross multiplication. All right. There's one on the exam that's like number 9 and 10. And that's why I wanted to make sure that we did that. So we have cross multiplication. So we have 3 times x minus 8 equals 30. And you can distribute first if you want to, or you can divide both sides by 3 first. Either one works. But most of you, I think, distribute first. Is that correct?
Yes, ma'am.
Then divide both sides by 3, and x equals 18. There will be one like that on the exam. Is everybody okay with doing those? You're basically cross multiplying. That's the reason why I encouraged you to go ahead and set up number 7 and 8, even though you can, Miss Richardson knocked it out of the park and showed y'all that shortcut. I want to make sure that you all go ahead and try to set it up in the form of cross multiplication, just because that way when you get ready to do them, when they're a little more complex, you're set up to do the same exact thing. Does everybody understand how to set it up cross multiplying?
Yes, ma'am.
Yes, ma'am.
Okay. I'm going to go back over here for another example because we've done those literal equations and we're going to do those literal equations again. But just to make sure that you all know exactly how to do them, I'm going to set up my own so that it's different from what we've done in class. Okay. I want you all to solve for x. What do I do? I'm trying to get x all by itself.
Divide by y.
Divide by y. Who said that? I didn't recognize the voice right off.
Addison.
Addison, you go, girl. That's it exactly. So your final answer is this. Does everybody understand why?
No, ma'am.
Okay. All right, let's talk about it. Good. Thank you for your honesty. I'm sure you're not alone. Okay. All right. I asked to solve for x. So we see where the x is. What is being done to x?
Being multiplied by y.
And how do you undo multiplication?
Oh, you divide. Okay.
Yes. Okay. So in your sweet little heads tomorrow during the exam, when you get to a problem and it's a literal equation like that, just ask what is going on around the variable that wants to be by itself. Like just pretend like Mrs. Sparks is asking you that question. What's being done to x? And Mary Faith, I believe you answered very quickly that it was being multiplied by y.
Yes.
And so then you would go, oh, well, Miss Sparks would ask me next, how do I undo multiplication? And you would tell me to divide, and that's where you get your answer. And then if I divide by y, those two are cancel each other out, and I get x all by itself, which was my goal. And now I have AB divided by y on this side, and that's as far as I need to go. I don't have to do anything else, but that's a literal equation. And I wanted to make sure we've done those others. I feel like we did the others in math lab last week. We did them in class, I think, twice. And so I just felt like those seem to be the ones where y'all get stuck a little more. So I wanted to make sure that we did one more just to have a fresh example before the exam tomorrow.
Okay, that makes more sense now. Thank you.
No problem. Thank you for asking for clarification, because I'm sure you weren't alone. I am happy to do number 11 and 12 again and walk through them if you guys would like for me to. I'm just, I'm sorry.
Can you do number 11, please?
I absolutely can. And let's talk about it so that tomorrow you'll think through it like that. Once this one, just like the one that Miss Sparks had as an extra example for you guys, it's asking us to solve for x. So let's ask the question, what is being done to X? What's happening?
It's being subtracted by K.
Yes, K is being subtracted from it. So how do I undo subtraction?
You add.
You add. Good job. Good job. So I'm going to add K to both sides. That cancels that out here. So now I have X all by itself, which was my goal, right? And I've got K plus W plus V, right? Because I can't combine those because none of those are like terms. So there's my answer.
Oh, okay.
That's all there is to it.
I feel like it's always those kind of problems that I overthink.
Yes, really just oftentimes that's kind of what happens because we panic, because everybody, a lot of times people, the common joke is that they really liked math until the alphabet got involved. But what this does for us is just reminds us it really doesn't make any difference if those were symbols, if those were letters. It doesn't make any difference what is there, what is being done to it is the principles of algebra, that those inverse operations always, you always do those things. To undo multiplication, we divide. To undo division, we multiply. To undo subtraction, we add. To undo addition, we subtract. All of those things still remain the same, whether it's a star, a triangle, a circle, a letter, a number. It doesn't make any difference. It's just when it's a letter or a symbol of some sort, you can't really combine things because you don't know what it represents, because this just represents some number. And so that's why you just do the operation. And as long as the letters aren't exactly the same, you don't have to do anything with them. Does that help?
Yes.
Absolutely, I can do number 12. Okay, it's asking us to solve for A. So let's take a look at it and talk through it and think about what's being done to A. There's a lot being done to it. So let's talk about what are some of the things being done to it. If it's in a fraction bar is really a type of what kind of problem?
A division.
It's a division problem. Good job. So we know it's being divided by B. All right. So we can undo that. And remember, if it's in a fraction bar, whatever is happening in one part of the fraction bar, that's kind of a grouping. So you want to deal with that last, because when we're doing those principles of PEMDAS, all right, so it's really a division problem. So how do we undo division? What's the inverse operation of division?
Multiplication.
Multiplication. Good job. Good job. So we would multiply both sides by B. So that gets rid of the B over here. And over here we have BU or UB, however you want to think about it, either way, because remember, multiplication is a commutative property, so it doesn't matter who goes first and who goes last. Okay, now we have just AK on this side. So how do we get A all by itself? What's being done to it here?
It's being multiplied.
It's being multiplied. And what's the inverse operation of multiplication? Good job. Division. So you're going to divide both sides by K. And that eliminates it there. And now, so that it looks like one of my answers, because I've got A first, I'm going to write A because that's all that's left over here, right? So A, nice A, Miss Sparks. And then UB over K. And there we go. There's our answer.
Can you do one more example that's like that?
Absolutely.
Thank you.
No problem. I probably shouldn't erase that quite yet. I'll just go to my blank piece of paper. That's a Z, by the way. All right, let's solve for X. What would I do first?
Divide.
Divide what?
By X. Everything by X.
We can't quite do that yet. Because the X is all the way on the top. It's in a grouping. It's kind of buried. And so if I divided everything by X, I would end up, let me just show you what would happen. Because I think a lot of people like to do that. So let's just see what would happen. If I divide this side by X, I've got this over here. So now I've got a complex fraction over here, which really looks like this. If I divide by X, that's X over 1, which is really multiplying by 1 over X. And that eliminates that over here. And now I have Y over Z equals MK over X.
Ooh, I don't like that.
So let's do something else first. But I'm glad that you said to do it because that's what a lot of people would do. But that's technically what happens. So let's think about something else we could do. What is being done to X?
Multiplied by Y.
It's being multiplied by Y. And what are y'all ignoring because y'all hate these? It's in a fraction bar, and I know y'all hate fractions with a passion, so you're trying to pretend like that Z wasn't there.
Would you multiply by Z?
Good job. You would definitely multiply by Z. That's what you want to do first to undo that division. Okay? So you get it, and this is going to be so much prettier. So that's what you want to do. Remember, do that PEMDAS in reverse. And if you have to, and I have a lot of students that do this, they actually write this at the top of their paper. And so when you're unpacking an algebra problem, you do this in reverse. Remember back in elementary and middle school, we did a lot of PEMDAS. We had to do order of operations. So you do parentheses, exponents, multiplication, division, addition, subtraction. But when you're unpacking an algebra problem to solve and isolate a variable, you're actually doing that PEMDAS in reverse. So you want to look for addition and subtraction. And if there aren't any, in this particular problem, there isn't, then you're going to look for multiplication and division. And remember, if it's on top of a fraction bar, that's really a grouping or parenthesis. All right, so now, how am I going to get X by itself now?
Divide by Y.
Divide by Y. 2 of you said it. Good job. Divide by Y. So that's my final answer. So, maybe the best way to think about it is, how much you all don't like fractions. Maybe when you see a problem like the XY over Z right at first, maybe the first thing you should do is let's get rid of that fraction. Think that in your head, fraction first. And then that way you'll remember to multiply to get rid of that denominator. Because that's going to be kind of a consistent theme throughout algebra, even with rational equations in algebra 2. So Yeah, just think about getting rid of the fraction because you don't like them. The good news for you guys is there's only one of those on the final tomorrow, and it's way easier than number 12 in the example that I just gave. There's only one operation to it.
Will it be multiple choice?
It is multiple guess for real. So but look at great question. I think that was Addison, right?
Yeah. Yes, ma'am.
Great question. But here's what I want to caution you about. Multiple guess is fun because you can like look down and, oh, my answer is there. But look at number 11, how close they all are. Like look at A and B, how close they are. So please, 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 my sweet children, be careful tomorrow. And my son-in-law is actually in the background, and he's the one that you all can thank for telling me to shorten my final and don't make it 50 questions. So he's actually standing here in my kitchen. So
You're welcome.
he said, you're welcome. But that is to make sure, and he said this was one of his reasons, to make sure that you all have plenty of time and you don't feel rushed and you look at those answers, because when it's multiple choice and you feel rushed, you might not really look clearly at your answers. Don't second guess yourself, but at the same time, please take your time. The final exam, let me tell you exactly. I think I told you guys, I couldn't remember if it was 38 or 40 questions. Oh, wrong final. Sorry. Trying to see exactly how many questions it is. It's 38. So that should get, and you all have an hour and a half to take it, I think, hour and 25 minutes. So that should give you plenty of time to be able to look at each one of them, twice, just take your time as you go through it. All right. Find the slope of each line. On number 13 and 14, you could have approached that from two different ways. You could have counted it, or you could have actually found the coordinates of each of the points that are highlighted there, that are like in the dots, like the coordinates, and then done the actual y2 minus y1 over x2 over x1. So I'll actually show that in both ways. If you counted it, going from the reading from left to right, starting at the left, I would go down 1, 2, 3, 4, 5, 6. So down 6 and right 1. So that's going to be -6. But if I would have used, how many of you did it that way?
I did.
I did.
Okay. How many of you would like to see it where you're doing the ordered pairs? Is there anybody in Math Lab that would like to see it that way?
Yes, please.
Okay. So my ordered pairs for this one, the first ordered pair was 1, 2, 3, 4. So it's -4. And then 1, 2, 3. So the first ordered pair is -4, 3. And the second ordered pair is 1, 2, 3. Is -3. -3. Did you get that, Mary Faith, for your ordered pairs? when you wrote
Yes,
them
ma'am.
down? Okay. So now y2 minus y1 over x1 minus x2. So that's going to be -3 minus 3 is -6. And -3, this makes a +1. +4, I mean, to equal a +1. So that would give me -6 over 1. Did you get that written down, Mary Faith?
Yes, ma'am.
Okay. Does anybody need me to do number 14, or do you want me to keep moving?
Can you do number 14?
Number 14? I sure can. Is that what you asked? That was kind of muffled. So
Yes, ma'am.
1, 2, 3, 4, 5, 6. I went up 6. And 1, 2, 3, 4, 5, 6, 7. 6 over 7. That's how you would count it. If I were doing just the points, this is 1, 2, 3, -3. I think that's -3 also. And then 1, 2, 3, 4. 1, 2, 3. So I've got my y2 minus y1 over x2 minus x1. So 3 plus 3 is 6, and 4 minus a -3 is the same as 4 plus 3, so that's 7. So if you count it or you use the coordinates of the ordered pair and plug it into the slope formula, either way works. Any questions on those? Okay, so now we have no graph, but we have just the ordered pair. So we're going to plug that into y2 minus y1 over x2 minus x1. So x or y2 minus y1, so 10 minus 7 over -2 minus 3. Does that make sense to everyone where I got that? Does anybody need me to write the slope formula just as a review? So 10 minus 7 is 3. And -2 minus 3 is -5. So it's -3/5. Number 16, -16 minus a -13 on the top. -18 minus 0 on the bottom. -16 minus a -13 becomes -16 plus 13, which will give me a -3 on the top. And -18 minus 0 is -18. So if I were to reduce that, it would become a positive because 3 goes into both. And I have a negative divided by a negative. So this reduces to a positive 1/6. Any questions about those?
No, ma'am.
Okay, everybody feel good about those? Trying to. On the final exam, just so that you know, there are going to be two, like number 13 and 14. I left a lot of the slope ones on there for better or for worse, for you make y'all happy or sad, but just to prepare you. And there's two just like 15 and 16. But that is something that goes with you to geometry. And it's something that's very, very important even for when we come back after January. So you will have two just like each of these on the final.
Miss Sparks, can you do number 17, please?
Absolutely.
Thank you.
And there are two like this also. Pretty much with the slope, if I were going to cut problems off of the final exam, it wasn't going to be the area of slope. All right, so find the slope of each line. What you'll notice is if you're asked to find the slope of each line and there's a y at the front, there is a pretty much 100% chance that it's in y equals mx plus b format. Does that make sense to you guys?
Yes. Yes.
Okay. So what would the slope be? Which letter in y equals mx plus b is the slope?
7 over 2.
I'm sorry?
7 over 2.
Yes. Yes, it's definitely 7 over 2. Because it's m. M is the slope. Remember, I said if you had to think of how to remember that letter, remember mountain and slope kind of go together. So it's going to be 7 over 2. All you're doing is identifying what it is within that. And that's just really important to remember because that's going to happen in geometry. It's going to happen next semester, and it's going to happen in the rest of this final exam. So I wanted to make sure that you all had great practice on that. Okay, so given that, what is the answer for number 18?
-4.
Yes. Did that seem kind of weird just because it seemed too good to be true, too easy? Okay. Yeah, those were kind of, those should be, but it's really, really, really important. Even as easy as a concept as that is, it's very, very important. So I wanted to make sure it was on the final exam because even when we come back in January, we're going to be dealing with that. You're going to have to be able to look at an equation just like number 17 and 18 and tell me what the slope is. Any questions so far? Okay. Find the slope of a line parallel to each given line. When we look at number 19 and number 20, they also are in the y equals mx plus b format. Okay? And that will be exactly like this on the exam tomorrow to find a line. So what I'm asking here is, can you tell me how are the slopes of parallel lines? What is their relationship? Can you tell me how parallel lines, what about their slopes?
Side. They're side by side. They're the same. They're
the same. Good job. Exactly the same. And somebody piped in and said -5, I think. And that is absolutely correct. That is the answer for number 19. And Eli, you were on point with the fact that parallel lines have the same slope. So if you answer in your mind, oh, parallel lines have the same slope. So Miss Sparks is just asking me to find the slope in this equation, and it is -5. So what would the answer for number 20 be?
B.
It is B, -4/5, because it is the coefficient on the x term when it's in slope-intercept form. Good job. All right. The next, and there's 2 on the exam exactly like that. So parallel lines have the same slope. And if Ellis is still with us, she knows the answer for this one. Perpendicular lines have what? What about their slope?
Reciprocal.
That's right. Opposite reciprocal. Except she draws a really pretty pickle, and I can't do that. Opposite. Maybe I'll write it. Reciprocal. I can't draw it, Ellis, but I'll write it. Opposite reciprocal. Okay, so what is the slope? And I'm not asking for the opposite reciprocal on this, but just tell me, what is the slope in this line? If I ask you what the slope of this line is, what would you tell me? Not the perpendicular line, but this line right here. What's the slope in this equation?
-1/2.
-1/2. Good job. So what would the opposite reciprocal of this be? The opposite of negative is?
+2. +2.
+2. Good job. Opposite reciprocal. Okay. What is the slope in this equation?
-1/3.
-1/3. So what is the opposite reciprocal?
3.
3. Good job. So there's 2 on the final exam exactly like that tomorrow. And it's worded the exact same way. Find the slope of a line perpendicular to each given line. And that's exactly what you'll do. Is everybody comfortable with that? Opposite reciprocal. Any questions? Okay, there's only one on the exam, like numbers 23 and 24. Only one of those. But does everybody understand what to do? You're looking for a line that goes through on number 23, goes through the x-axis at the point of -4. So we could say this one does, this one does not, this one does not, and this one does not. So this one's pretty easy. This is the only one that goes through -4. But if you had multiple choices, you would want to double check and see that it goes through the y-axis at the point of 2. The ordered pair for this is -4, 0. The ordered pair for this is 0, 2. All right, so number 24, the x-intercept. It has to go through the x-axis at the point of 4, 0. So A is a possibility. B is not. C is not. Oh, but D is a possibility. So we go back up here and it's asking us, where is it going through at 2? So that's going to be 0, 2. A does not. That's -2. So that doesn't work. So the answer should be D. And yes, in fact, it is going through at 2. There's one on there that is like number 23 and number 24. Is there any questions on that? Is everyone confident about how to do those?
Yes, ma'am.
Okay. Number 25. So what you're going to do is it asks to sketch the graph of the line. All right. Whenever you're asked to sketch the graph of a line, the best thing to do is to get it in slope-intercept form if it is not already there. Can anyone tell me, is number 25 in slope-intercept form?
Yes.
Yes, ma'am, it is. Thank you very much. What is the y-intercept on number 25?
-4.
-4. Good job. B equals -4. That is the y-intercept. Okay, so which one of these graphs is going through -4? A, B, C, or D?
C and D.
Good job, C and D. Good job. So we can eliminate A and B. What is the slope of this line?
2.
2. So what we're going to do is hop on to, and it's positive, right? All right. So there's only one of these two lines that is rising from the left to right. Which one of these two is rising from left to right? Because remember, a positive slope, reading a graph from left to right, rises from left to right.
C.
C, good job. And just to confirm, it's going up 2 over 1. Up 2 over 1. And this one is going up to left 1. So if I went up to left 1, that's negative. This is up to right 1. Does everybody see the difference?
Yes.
Yes.
Okay. Here's another thing. I'm just going to sit here for just a minute and give everybody just an opportunity to look at C and D and look at the difference and see if you can understand what I mean by rising from left to right. Does everybody see that?
Oh, yeah.
Because if you're, I just want to give you a minute to let that sink in. For me, some of this visual stuff is a little harder. So that's why I probably give a little extra time here. If you're reading, just like if you're reading a book and we're reading stuff from left to right, this is actually rising from left to right. This is actually falling from left to right. So that's how you tell the difference with whether something is negative or positive. Does that help a little bit?
Yes.
Okay.
Yeah.
All right. Let's take a look at number 26. What is the y-intercept on number 26?
+1.
+1. Good job. Good job. B equals 1. That's the y-intercept. All right. What is the slope on this one?
3/2.
3/2. Good job. And it's positive. So we know for sure we're going to have something rising from the left to the right. And we also know it's going to go through +1. Well, it looks like A goes through +1. B does not go through. It's going through -1. C goes through +1. D does not. It's going through -1. So we got it narrowed to A and C. Just based on positive and negative alone, what do you think the answer would be? Which one rises from left to right?
C.
That's right. Good job. It sure does. It's rising from left to right. And since we know it's positive, we know that it's gonna go up 3, right 2. So basically goes 1 and then 2, 3, and then right. That's actually, this was more like 6, but then over there. But just based on positive, negative. Does that help you guys kind of read them a little bit based on positive and negative?
Yes, ma'am.
There are 2 on the exam that are like that one. All right. Number 27 and 28. Are these in slope-intercept form?
No.
No, they are not. So you cannot graph a line with an equation unless it's in slope-intercept form. So the very first thing that you're going to want to do on these is change them into slope-intercept form. So what would I do first? These are like those literal equations, kind of. So what am I going to do first?
Subtract 3x.
Good job. Subtract 3x from both sides. So that gives me, that cancels that, and that gives me y equals, and to be in slope-intercept form, I want that -3x to go first. Okay? So now it should, my equation should look like y equals 3x, -3x minus 5. All right, so what is my y-intercept?
Can you
Anybody
repeat
know
the
the what is the y-intercept with in our new equation?
-5?
-5. Good job. So b equals -5. What is our slope?
-3.
-3. Good job. Okay, so let's take a look at some of these lines. Which one is going through -5? Kind of looks like A is. B definitely is not. Looks like C is. And D is definitely not. All right, now let's see if we can indicate this slope is negative. So that means it's going to fall from left to right. Of A and C, which one is falling left to right?
A.
Good job. It is. It is. Hold on just one second. I'm sorry. Good job. It is definitely falling from left to right. It's going through 5. Whoa, that's scary. And falling from left to right, going up 3. And I'm kind of trying to focus on that because sometimes those graphs, because they go in increments of 2, they're a little harder to read. But all right, so number 28, is it in slope-intercept form? Are y'all still with me? Okay. It is not. So you have to get it in slope-intercept form. What am I going to do first?
Subtract the 4x.
Good job. Subtract 4x from both sides. Now what am I going to do?
Divide by 5, -5.
Good job. Divide by -5. Good job. So that cancels here, and that gives me y equals -4 divided by -5 is going to be a positive 4/5 x. A -20 divided by -5 is a positive 4. Okay, so we're looking for one that goes through 4 and has a positive slope. Goes through 4 and has a positive slope. This goes through -4, so that's not a possibility. This goes through -5, so that's not a possibility. This one's going through the origin, so it's not a possibility. We got it all narrowed down just based on our y-intercept on this one. This is the only one going through 4. And it also, just to confirm that we did everything right, also has a positive slope because it's rising from left to right. So it is D. Any questions about that one? There is one exam that's like that. But it is more like number 27 than 28. You won't have to divide anything. Does that make you relieved?
Yeah.
But it's very important that you guys know how to do it. But, all right, are any questions about that? Okay, write the slope-intercept form of the equation of the line. There's one of these on the exam. What I would do here is find my intercept. So where is it going through the y axis? Non-number 29, where is it crossing the y-axis? Because what I need to get the slope-intercept is the slope and the y-intercept. So where is it crossing the y-axis?
4. -4.
-4. Good job. So B equals -4. And now I need the slope. And that's the only thing I need to get it in slope-intercept form. So I want to count. And I want to be cautious when I do this because look, sometimes this one actually looks like it's labeled okay, like 1, 2, 3, 4. So we're a little better off on this one. You just want to be careful how things are labeled. So we're going to go, you want to look at your next closest point where it crosses a solid grid, where you have a solid integer. And it's going to be there. So I went up 1 and right 2. Up 1 and right 2. Does everybody see how I got that? Up 1, right 2. And just to confirm that, up 1, right 2. Up 1, right 2. So M equals this. So now I have the slope and I have the y-intercept. So if I put those two together, I can write it in slope-intercept form, which is this. All I'm going to do, why don't you guys tell me what to write? Somebody tell me.
Y equals 1/2 x minus 4.
Good job. Perfect. Genius. And it's C. So that's all you have to do is you need to write it in slope-intercept form. You need to figure out where it crosses the y-axis and what the slope is. Okay, so number 30, let's do the same thing. It's weirdly crossing the y-axis in a kind of a weird place. I hope y'all can read it. What would you say that the y-intercept for this one is?
-5.
-5. Good job. It looks like it's just barely crossing there. So that was a little hard to read. So good job. Thank you very much. Okay. So then we want to look for where's the next spot that it's kind of going through, which I think it's right here. So we're going to count our slope. 1, 2, 3, 4, 5. Looks like it's going up 5, but left 1. So that gives me a -5 for my slope. So now somebody tell me what to write.
Y equals -5x minus 5.
Perfect. That's it exactly. And that is answer D. Good job. Way to go. Good teamwork on that one, guys. And a lot of times I will go ahead and actually write my answer just to make sure on a multiple guess that I get the exact one that I'm looking for. Just as a reminder there, a little test taking strategy, if you will, for that. Okay. Any questions about 29 and 30? There is one of those like that on the final exam. There was 2 on the review. There's 1 on the final exam. Okay. Now, number 31, 32, 33, and 34. Write the slope-intercept form of the equation of the line described. There's 4 on the final review for parallel lines, and there's 2 on the final exam. There's 4 on the final exam review of perpendicular lines down here, and there's 2 on the final exam. So let's start here. What do we know once again about parallel lines? They have the same what?
Slope.
Slope. Good job. So what is the slope of the line for this one? Kind of already wrote it for you, but all right. So the slope is going to be 3/4, and it goes through this point. So we're going to plug in, because what is going to be different about them is that y-intercept, or that b. That's what's going to be different about these two lines. Same slope, different y-intercept. So we're going to solve for b to find out what that y-intercept is. And we're going to do that by using this point that's given. So we'll plug in 3 equals, let me write that slope-intercept over here. 3 equals 3/4 times 4 plus b. Simplify before you multiply. Subtract 3 from both sides, and I get 0. So I would write y equals 3/4 x plus 0, but that doesn't look like any of my answers. But does this really add value? If I add 0 to anything, I haven't really changed the value. So we can write it like this, which is one of our answers, and it's this. All right, a little more help on this next one, guys. Tell me what the slope is on number 32. Parallel lines have the same slope. So what is the slope of the line that's given?
1.
1. Good job. Thank you, Eli. And what is going to be different is going to be this b, where it crosses the y-axis. So once again, we will plug in this point that's given into the slope-intercept form. -2 equals 1 times 2 plus b. And we're going to solve for b because that's what's going to be different. So -2 equals 2 plus b. I'm going to subtract 2 from both sides. Gives me -4 equals b. Now, somebody tell me exactly what to write this equation in slope-intercept form. It's got this slope and this y-intercept. What do I write?
Y equals x minus b.
Yeah, what is the b?
Negative 4.
Good job. So which one is that? There you go, B. Good job. Way to go. Thank you, Eli. Okay.
More sense.
I'm sorry?
I said that makes a little more sense.
It does?
Yes.
Okay, good. All right, let's walk through number 33. What is the slope of the line given?
5.
5. So, and it's asking for parallel lines, and parallel lines have what? The same
Slope.
Yep, they have the same slope. Good job. Parallel lines have the same slope, different y-intercept. So we're going to plug in the given point into the slope-intercept form to find that b that will be different. So we've got 0 equals 5 times -2 plus b. 0 equals -10 plus b. All right, I'm going to add 10 to both sides. So I get 10 equals b. So now somebody help me. I've got a y-intercept of 10 and a slope of b. Help me write this new equation to this line. What would I write?
Y equals 5x plus 10.
Plus 10. Good job. And that is which letter? C.
C.
And see how close B and C are? That's why I'm saying be very, very careful tomorrow. Okay, guys? Multiple guess is delightful, but it also can be tricky at the same time if you're not cautious about your answers. So I'm really praying very hard for that, for all of you. To be on the lookout when you're writing that. Okay, number 34. What's the slope of the line given?
-10.
-10. Good job. So we're going to plug into the y-intercept form. Got -5 equals -10 times 1 plus b. So -5 equals -10 plus b. I'm going to add 10 to both sides to get that b all by itself. And I've got 5 equals b. So my slope is -10 and my b is 5. So somebody tell me what to write this new equation of this line that's described.
Y equals -10x plus b. Oh, sorry, plus 5.
-10x plus, oh, whoops. I did the same thing. I wrote exactly what you said. Plus 5. All right. Good job. Which one is that?
A.
Good job. A. How are you all feeling about these now?
Good.
Good. Everybody good on these? Okay, there's 2 like this on the exam tomorrow. 2. Parallel lines have the same slope. Moving right along to perpendicular lines. Ellis, perpendicular lines have what? Oh,
Opposite reciprocal.
that's right, opposite reciprocal. Did somebody else have a question about the other?
These questions, please, anyone?
Did you ask how many were on the exam?
Yes, ma'am.
2 parallel line problems just like that. Opposite reciprocal. Okay, so the line, the slope of the line given here is what? What's the slope in this equation right here? Can anyone tell me what the slope is on that equation that I just circled? On number 35, what is the slope of this line?
5/3.
5/3. Good job. Thank you, Eli. Okay, what is the opposite reciprocal of 5/3?
-3/5.
-3/5. Good job. Thank you so much, Eli. The cool thing about this is we really wouldn't have to go any further than this. Can anybody tell me why?
Because it's in
Because we
slope.
can already see the answer.
Yeah, right. There's only one answer that has that. -3/5 as the slope. And we know beyond a shadow of a doubt that the slope has to be -3/5. But I'm going to go ahead and work it out because I can't guarantee that on the final it's going to be like that. I think it is, but I'm not going to make any promises, and you do need to know how to do it. So I'm going to work it out, but I did want to do that test taking strategy. This literally is the only one that it could be because it is the only answer that has -3/5 as the slope. Does everyone understand that? But just in case, we've got 2 equals, and then -3/5 times -5 plus b, because you're going to do it the exact same way that we did the parallel lines, but this time instead of putting the same slope into the slope-intercept form and substituting that point, the ordered pair into the y and the x, we're going to be doing the opposite reciprocal. So we've got 2 equals, and then you can simplify before you multiply. So we've got -3 times -1. That's going to be a +3 plus b. Subtract 3 from both sides. Gives me a -1 equals b. And lo and behold, that is exactly what that one is. So basically the process of the problem is the exact same as the parallel lines, because the difference is you've got a little bit of a different slope and you have a different y-intercept. So you're solving for that different y-intercept. Okay, what is the slope on this line? What's the slope there?
1/6.
1/6. Good job. So what is the opposite reciprocal of 1/6?
-6.
-6. Good job. Thank you, Eli. So we will substitute in 3 equals -6 times -1 plus b. 3 equals -6 times -1 is a +6. Subtract 6 from both sides. -3 equals b. Okay, so it would be y equals -6x minus 3. All right. What is the slope of this line?
-1/2.
-1/2. So what is the opposite of -1/2?
-2. +2.
+2. Good job. You are absolutely correct. So we would plug in -2 equals, and then our new slope, our opposite reciprocal slope is 2 times -1 plus b. So negative 2 equals negative 2 plus b. Add 2 to both sides. That cancels here. So our b is actually 0, kind of like one of our parallel lines was. So basically, we have y equals, and then 2x plus 0, but that's not important because when you add 0 to anything, it doesn't change the value, so you can write the equation just like this. And here's your final answer, which we would have known at the beginning because it's the only one with the correct slope. After we figure out that it's the opposite reciprocal, it's the only one with the right slope. Are you all getting these? Is this helping? Is it bringing the
Yes, ma'am.
good? Is it kind of bringing the semester together a little bit?
Yeah.
Okay. All right. What is the slope of the line given on this one? What is that slope?
Five.
Yes, close. Negative 5. So the opposite reciprocal is
Positive 5.
and the reciprocal. The opposite would be positive, yes. And then the reciprocal of 5 is a negative 5. The reciprocal is what?
1/5.
Yes, 1/5. Good job. 1/5. So I'm going to plug in my ordered pair. 5 equals, and then my new opposite reciprocal slope, 1/5 times 5 plus b. And then I'm going to simplify before I multiply. Then I'm going to subtract 1 from both sides. And I get 4 equals b. So I'm looking for an equation that has 1/5 as the slope and 4 as the y-intercept. Feedback is bad. All right. Any questions about parallel and perpendicular lines and their slopes and all of that? Any questions there? Okay. Write the point slope form. Anybody remember what that looks like?
Y equals mx plus b.
That's the slope intercept. Point slope looks a little different. Anybody remember? Does that ring a bell? So you're going to have a y in there and an x in there, and you're just going to use this point and the slope and plug those in. You'll plug in the y coordinate here and the x coordinate there and the slope here. So tell me what to write. Anybody?
2 minus y1 equals 1/3.
Oh, I think that was number 40. I know I wrote that over here. We're working on number 39. You were working, that was definitely the ordered pair for number 40.
Would it be y minus 4
Yes.
equal negative 1/6 times negative 1? Or no, x minus negative 1.
So x minus negative 1 then looks like what? If I have a minus minus, what is that?
Plus.
Yes. Hold on just 1 second, guys. I'm really sorry. Sorry about that. Okay. That is absolutely correct. And let's see which one of those was that. C, 39, C. All right. Let's work on number 40. And I think, Eli, you were starting to tell me this one. Because I had written that equation over number 40, so I can see where that would have been confusing. But I think you had started to tell me this one. You had said you started with y, and remember in the point slope form that the y, the generic y, is always going to go first, and then your point, whatever that is, will be the second one. So y minus 2 equals, and then you put in your slope, 1/3, and then you would have x minus a minus 5. So then that goes to y minus 2 equals 1/3 x plus 5. Does that make sense to you guys?
Yes, ma'am.
Okay. So number 40, and let's see, on the final exam, let me see. There are 2 like that, just like there are on the exam review. There's 2 of those. And then there's this one, right? The slope-intercept form of the equation of a line. There's 2 of those. Okay, so the slope-intercept form is this one. Right here. Okay. So what do I do first? To get it in that form, what am I going to do first? Anyone? No one knows what to do first to get it in slope-intercept?
Would you subtract x?
Yes, subtract x from both sides. Good job. So I got negative y equals negative x plus 2. I can't have a negative y, so what am I going to do?
Add everything by it.
I can't add. So the only way to actually change the sign on the front is to multiply everything by a negative 1. That is all you do to change the sign, is multiply or divide, either way you want to think of it. But since a lot of times what we do to change a line is to multiply, I like to keep it relatively consistent. But so you would multiply everything by -1. And all that does is change the sign on every single term in the problem. So it changes my opposite of y, or -y, to a plain y. It changes my opposite of x to a regular x. And it changes my +2 to a -2. So now I have y equals x minus 2. And that is C. Does that make sense, Eli, to you? Why you do that?
Kind of.
Kind of? All right. Well, I appreciate your honesty. Let's keep working on that. Thank you very much. I'm sure you're not the only one a little confused by that. So let's, it actually happens again on number 42. So let's take a look at it again. Okay, so number 42. 3x minus y equals -4. I think that's gonna be too cramped right there. I'm gonna actually, I don't know if, will it confuse y'all if I do it down here? Because I have more white space here. 3x minus y equals -4. All right, so still cramped. I want to make sure that I have enough room where y'all can really understand it. So the first thing I'm going to do is what? To get y all by itself, what am I going to do?
Subtract the 3x.
Subtract the 3x. Good job. So that gets rid of this. And now I have -y equals -3x minus 4. Now, I can't have that -y. In order to change the sign on something in math and not change the value, because if I multiply anything by 1, it doesn't change the value at all. If I multiply by a -1, it doesn't change the overall value, it just changes the sign. So what I want to do is multiply everything by -1. So if I multiply -1 times -y, if I multiply two negatives, that becomes a positive. So now I've got y. That's that part, right? Does that make sense? Or not really still? And now, if I do multiply a -1 times a -3x, all it does, it doesn't change the 3, it just changes the sign on the 3. So it goes from -3x to a +3x. And now I'm going to multiply that -1 to the -4. So that's like -1 times -4. A negative times a negative is a positive. So now my answer is y equals 3x plus 4. And the ones on the final exam are very much like these, where you're going to be having to multiply by that -1 as your final step. Because that y has to be positive. Okay? Is that better for you guys or still a little confusing?
Definitely.
Is confusing or better?
Better.
It's better.
Okay. Okay.
Definitely better.
Okay. All right. Well, make sure that like what I would do later on, guys, after math lab, you know, any one of these that were a little confusing, you can always star them, you know, and go back and try them yourselves again on a separate sheet of paper and make sure you know what to do. Okay. All right. Write the standard form of the equation of the line. All right. So the standard form is AX plus BY equals C. So that means my X term and my B term, or my Y term, I'm sorry, have to be on the same side of the equation. So on this first one, I've got Y equals negative 10 thirds X minus 4. All right, so how do I get my X term on the same side as my Y? What am I going to do with a negative 10 thirds X? What am I going to do? I'm sorry?
Add it.
Add it. Good job. Because the inverse operation of negative or minus is to add. So I'm going to add 10 thirds X to both sides. So now I have 10 thirds X plus Y equals negative 4. Okay, well, remember we can't have a negative or a fraction leading the equation. So when it's a fraction, we always multiply by the what? We multiply the whole equation by what?
-1.
Not in this case. That's only when it's a negative leading the way. Do we multiply by a -1? That gets rid of the negative. But when it's a fraction, in order to get rid of the fraction, what do we multiply by?
The denominator.
Yes, good job. So when it's a negative leading the way, you've got to multiply by a negative something or other. And when it's a fraction, you multiply by the denominator. Multiply every single thing. And so here's my side work over here. When I'm multiplying this, 3/1 times 10/3, simplify before you multiply. And the whole reason we're doing it is look how pretty that is. It's just a plain old 10 now. So it's a 10x. And now when we multiply 3 times y, what do we get?
10x plus 3y equals -12.
Yes, that is what we get. But so what you're doing is now multiplying by that y. 3y equals -12. Because 3 times -4 is 12. So we multiplied every single thing. So look how close A, B, and C are. So if you hadn't written it out yourself, you might have guessed the wrong thing. Because see how close they all are? All the numbers are the same. You just don't have them in the right order with the right letter and all of that stuff. That's why I want you guys to be so careful tomorrow. Everybody gets excited about multiple guess, but they also can be tricky. And there's one tomorrow where you're going to have to multiply by the denominator. So when you get a fraction leading the way, remember, what do you multiply by?
The denominator.
The denominator. Ruthie, Eli, are y'all good with that?
Yes, ma'am.
Okay, good job. All right. So let's take a look at number 44. So how do we get it in standard form? What are we going to do first?
Add 4/5 x.
Add 4/5 x to both sides. Good job. So now we have 4/5 x plus y equals -3. So we've got a fraction leading the way. So we're going to multiply by what? The
Multiply by 5. Denominator.
Yes, multiply by 5, the denominator. Multiply everything in the equation by 5. And so when you multiply the 4/5, that gets rid of the 5 in the denominator, which was the whole goal. Oops. Right? But now we have to multiply that 5 times the y. So 5 times y is what?
5y.
5y. Good job. And then 5 times -3 is what?
-3.
5 times -3. Yes, sir. What is that? 5 times -3 is
-15.
-15. Good job. So, here's your answer. But look, B and A are pretty close. So just be very, very careful, please, tomorrow. And C would be close if you didn't multiply, if you only multiplied the first one by 5. That would be the answer. So they've got it in several ways to kind of trick you. So please, please, please be careful. All right, now we're kind of back to the -1 thing on this last one, okay? So let's work that one together so we can remember that when the leading term has a negative on it, we multiply everything by a -1 in order to change it. So that's number 45. Y equals 5x plus 1. So what's the first thing we're going to do?
What was the question again?
What's the first thing we're going to do to get this one in standard form?
Subtract 5x.
Subtract 5x from both sides because your x term and your y term have to be on the same side in order to be in standard format. And now we have a -5 leading the way. And in order to get rid of that, what do we multiply the whole thing by?
-5.
We do want to multiply by a negative, and we could multiply by a -5 if we wanted to. It would just take us way, way up there. We'd have like a 25. It would be an equivalent fraction or equivalent equation, but if you multiply the whole thing by -5, it would be 25x minus 5y equals -5. And that isn't one of our answers. It is a non-negative. So think of something smaller that would do the same thing, that would get rid of that negative. You know what I'm saying? It would get rid of the negative, but wouldn't. Yes, good job. Good job. Awesome. So that's going to make that a positive 5x. The -1 times the y is going to make that. It's just changing the sign of every single term all the way across. And look how close all of those answers are on number 45. So please, please, please be careful tomorrow. Which one is our right answer?
C.
C. That's why it's a lot of times a really good idea to go ahead and work these things out yourself and then look for your answer and be cautious when you do it. Okay. Number 46, only 4 more. Are there any other questions about these? If these are the ones that you struggle with, please do them on a separate sheet of paper later and go back and check your answers. Best way to study for math. All right. Good news. There is a compound inequality on the final exam review, but there is not a compound inequality on the final exam. There's only an inequality, and it's much simpler than even the one I gave here. Okay? But it was just important that you all know that. Okay? Understand these. 3 is greater than K over 14 plus 4. Remember to do PEMDAS in reverse, even if you have to write it on your paper. All right. Is there any adding and subtracting going on?
Yes.
Yes. So you want to do that first. All right. So where is, what were you going to tell me? Subtract 4?
Yeah.
Praise the Lord. All right, so that's going to give me a -1 over K divided by 14. All right, so I said K divided by 14. To hint, what do we do next? We undo that division. How do we do that?
Multiply by 14.
Multiply by 14. These are just like regular algebra problems. There's just a funky symbol in the middle. So -14 is greater than K. And remember, Miss Park says it's always easier to graph your answer if your K leads the way, but make sure that you keep your greater than less than symbol facing the right direction, and it's pointing toward K here. So we want to keep it pointing toward K. So K is less than -14. So there's our answer right here.
So the answer would be D.
Yes, ma'am. All right. Number 47. Okay, 47 is a compound inequality, so that means it's 2 small algebra problems kind of combined. And your first one is this, and your second one is this. So we'll solve this first by subtracting 3 from both sides. And here we're going to subtract 3 from both sides as well. So we have -9. Well, let me just do this. You could 2 ways you could write it. Actually, yeah, we better do it that way since the answer is like that. -9 is less than K is less than or equal to 2, which means I'm going to have an Oh, that's a -5. That's a horse of a different color. So there we go. Didn't write the problem down right. That's always a problem. So there's your final answer. We've got to open circle on -9, a closed circle on -8. And there's my final answer. And now number 48 is an or. So we've got two little algebra problems. Subtract 7 from both sides.
Wait, can you go to number 47 real quick?
Which part did you need?
Oh, hold on.
Huh?
Hold on 1 second. I'm trying to figure out where this. Oh, okay. Now I see it.
Were you like Miss Sparks and didn't write the problem down right?
No, I did -7. Sorry, I did -6. Plus 3 is -3, but that's not right.
Oh, I got you. Good job checking your work. The other part of this one is n/2 is less than -3. And to undo division, see the fraction. I know y'all hate those fractions. Get rid of those first, right? So now you've got n is less than -6. So this is an or. So it's open circles at +6 and open circle at -6. So this one is B. And now 49 and 50. And there's one problem like this on there, and it's more like number 50. Okay, on the final exam. But we're going to do both 49 and 50. But the final exam problem is much more like number 50. So make sure you know how to do that. With an absolute value, you know that it can be +56 or it can be -56. You're going to have two answers with absolute value equations most of the time. Going to divide both sides by 8. And you're going to get 7 here. And you're going to get -7 there. So here's my answer. On this one, 8 plus r is going to equal 2, or it's going to equal -2. So I'm going to subtract 8 here. That gives me -6. Subtract 8 here. And it's going to give me -10. So A is my answer. Two possible answers. Right? So we got through the whole exam review. Are there any questions? And you all, I think I posted this on Google Classroom, but there's the answers also.
Thank you, Miss Sparks.
You're most welcome.
See you tomorrow.
All righty. Praying for y'all.
Thank you so much, Miss Sparks.
You're most welcome. Love y'all. Bye-bye.